So probably the first model of bonding that you ever learned about was the Lewis structure. So let's think about that with respect to oxygen, superoxide, and peroxide, three different dioxygen species. So the first question says to draw the Lewis structure for these. And so you remember how to draw a Lewis structure, right? You start with the valence electrons. So here, oxygen has 12 valence electrons. And you draw the two oxygen atoms, and you add two bonds. So that's 1, 2, 3, 4 electrons. And then you fill in the rest, 5, 6, 7, 8, 9, 10, 11, 12. You can do the same thing for superoxide, which would have 13 electrons. So you can fill those in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this has an unpaired electron. And we see that the oxygen that I've drawn here on the right has a formal negative charge. Finally, we can do peroxide, which would then have 14 electrons. And once again, we can draw the two oxygens. That gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 electrons. So in this case, each oxygen has a -1 charge. Okay, so if we look at these Lewis structures and think about the bond lengths for dioxygen and superoxide and peroxide, can we understand this relationship? Okay, so if we look at, so oxygen has the shortest bond. That makes sense because it has a double bond. And peroxide has the longest bond, and that makes sense because it has a single bond. But understanding superoxide, so superoxide is in between, but maybe a little bit closer to oxygen. In our Lewis structure, both superoxide and peroxide have a single bond. So that doesn't necessarily, it's kind of difficult for us to account for why those bond lengths would be so different.